Hello students, this is our fifth class on combination of capacitors. So today we are going to solve few more number of interesting problems on combination of capacitors. All the capacitors are in a cubical structure. So you have to find out the capacitance between the two terminals of the capacitor. So in the last video, in the video number 1, so video number 4, we have solved the net capacitance of a cube structure, 12 number of capacitors about the body diagonal of a cube. So about the body diagonal, see this is the body diagonal, this is called the face diagonal, this is because this is the one face of a cube. So now this is the face diagonal and this one is about one edge of the capacitor. If this is the edge, so there are 12 edges in a capacitor. So you have to find out what is the net capacitance between the point A and B. It is called edge of the capacitor. This is called the cube of the diagonal of the capacitor, body diagonal of the capacitor. This is called the face diagonal of the combination of the capacitors in a cube. So now this part already we have solved. Now this answer was found to be 6C by 5. So that is 6C by 5 about the body diagonal of a capacitor of a cube. That already we have solved. Today we are going to solve another problem. So about that is about the face diagonal of a cube. So now after this one, then we are going to solve about the one edge of the capacitor. So I am D.N.Thatoi. Welcome you all to my YouTube channel, new YouTube channel, Physics Sketch. So let us come to solve the question number. This one, the answer for the about the body diagonal will be 4C by 3. So about this it is 6C by 5, and about one edge it is 11C by 7. So now we are solving one by one. You just follow. So now to get the capacitance between the one diagonal of the cube, that is the face of the diagonal of the cube. So now let us draw the diagram. Now let's say this is the cube. There are 12 number of capacitors at the edge of the cube. Now I want to find out the net capacitance between the one edge, that is about the diagonal of a face. This is the face of a cube, and AB represents face diagonal. Face diagonal of a cube. So about the face diagonal of a cube, we are interested to find the capacitance. To find the capacitance, let us connect a battery. The process you just follow step by step. I am going to solve the problem. Let us connect a battery here. Between the point A and B, I have connected battery. Let the potential of the battery be V. So now we will follow the same pattern, the way I have explained in the last class. So now you just recall what I have told you. Now when the charge will be reaching here, the charge has 3 paths to flow, and finally they will come at the point B, because this is the entry end, B is the exit end. B stands for the exit and A stands for the entry, because the battery is connected between the point A and B. So when it will enter here, so all the charges will flow in different capacitors, then finally they will come out at the point B. Now we have to find out how many minimum paths a charge will flow when it will going this way. So when the charge will flow this way, so how many minimum capacitors it will pass? The minimum number of capacitors it will pass before reaching the point B is 1 and 2. If the charge will go this way, again the minimum number of capacitors is 1 and 2. So since the minimum number of capacitors along this path or along this path are same, then let's say the amount of charge flowing here is Q, the amount of charge flowing is Q. Or you can say the amount of charge flowing in this path is X, the amount of charge flowing in this path is X. No problem. So only naming. So again you see, since entry and exit are identical, so here it is going this way and reaching here. So here it is X. In the previous video, you just try to understand. Go and see the previous video. There I have explained, if this is X, this will be also X. So if this is the X, this is also X. So the minimum path along this line is 2. The minimum number of capacitors along the line is also 2. So entry and exit are symmetric. Since entry and exit are symmetric, if this is X, this will be X. If this is x, this will be x. Now, if another charge will go along this path, the minimum number of capacitors to reach this point is 1, 2, 3, 4. The minimum number 1, 2, 3, 4. Any path you found, minimum number is 4. That's why. So if this is x, it will be different. It is not x, because along this line minimum path is 2 only capacitors. Along the line only minimum number of capacitor 2. That's why they will get the same charges x each. But here the minimum number of capacitors it is to go is 4. So this is y. If the charge going is from the entry point, it is y. So exit end it will be also y. This part already we have discussed in the previous video. So now, as I told you, if the same x charge is going here, so the potential of the point, if say P, then potential of this point is also P, because same charge is flowing, capacitance is same. So potential drop will be same here, potential drop will be same here. That's why potential of this point is P, potential of this point is also P. Come to the other side. So along this line, so now, yes, along this line the charge is going x, along the line charge is also going x, then another line the charge is going along this y. So now come to a point here. So at this point B, let us see at the point P, when the charge is coming this way, the same charge is going this way. The charge that is coming here, the same charge is going here. Now come to this point and let us discuss the importance of this point. Come to this point. About this point, so now this is a capacitor. Now the name of the point is P. So there is a capacitor. Now the point is B and there is a connection. It is observed that charge X is coming here and same charge is going along this line. That means this capacitor does not carry any charge. So here the charge Q is equal to 0. So this type of problem already we have solved. Now, since the same x is going here, the charge along this line will be 0. Similarly, if the same x is going here also, the charge in this capacitor will be 0. Because the same x is going here, again it is going straight to the point B. So, though it is a connection, no charge is coming to the point, no charge is going out of this point. So, the same x is going because of the symmetry I have explained. So, if no charges are going this path along this path, now our problem becomes made easy, then we can solve the problem quickly. So look how I am solving. So very important part is there. So this charge does not carry charge, this path does not carry any charge. If the both the paths they will not carry any charge, what to do next? So look how to do what I am explaining. So look here. So I have told you that no charge is flowing. If no charge is flowing, so next duty is, so I have to see that no charge is flowing means this path is a redundant. So this is no role in this connection. So similarly, this is a redundant path and no value of this connecting here. Now this is my modified circuit. Now the circuit is modified. Once the circuit is modified, then you know that these two will be series now, 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 then this one, this one, this one. So this one, they like this. Then we can able to reach our solution. Now come to the solution part. So here let us count name of the point is A. Look, so I am drawing again. This is the point A. Name of the point D or the name of the point B. This is B. Name of the point is B. Now from the A to B there is a capacitor C and C. So now come to this point. There is a capacitor C. Then it is coming to the point B. This one. So C and C. So now this C and this C combined it will coming to be C by 2 because series. This is C, this is C. They are in series. This two is series. So this will be C by 2. Now between this it is equal to C by 2. And these two are C by 2. Then come to the point here. Another capacitor is going this way. So this is C. From the B point, another capacitor going. This is C. And these two are in series. C by 2. This is C by 2. Again from this point. So now we can say this is one connection. This is another connection. These two are combinedly called that is C by 2. these two are combinedly as a series. Series means reciprocal sum C by 2, then this is C by 2, this is C by 2, so it will be parallel C, 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 C. Then again let us draw the diagram to get the capacitance. This is the A point, this is the B point, this is C by 2, this is C by 2. So they combinedly become C, parallel connection. These two, they are parallel, so net capacitance is C between A and B. This is A point, this is your B point. Again, this is C, so this is C by 2, this is C by 2. It will be C, again it will be C. So C, this is C, this is D, and these two are in parallel. So parallel means direction. So C, C, C. So next path follow when you will draw the diagram here again. So this is the end of part of the last part of the diagram. So this is your C, then this is C, this is C, this is C. So these three are in series. If these three are series, then it will be C by 3. It will be C by 3. So end points are A and B. Now the net capacitance between the point A and B. Now I am reaching the solution. So now the net capacitance between the point A and B is they are parallel. So the net capacitance between the point A and B is how much? They are parallel. So it will be C plus C by 3. It is equal to 4C by 3. So that is what I have written. So the net capacitance between the about the face diagonal of a cube. About the face diagonal of a cube is 4C by 3. About the body diagonal, it was found to be 6C by 5. That is the end of this problem, and the solution is 4C by 3. Okay, this problem is over. Okay, so please note down. Then we will go to another problem, that is about the edge of the cube. That will be the last problem regarding the capacitors connected along a cubical structure. These are all easy. So when things seems to be very difficult, but if you draw them and appropriately by using the concept of potential, common potential, equipotential points, all equipotential points are made to a single group, then the net capacitance can be obtained very easily. Okay, now we will go to the capacitance, where the capacitance will be about the edge of a cube. Look here. So now this is the cube. This is your cube. So now this is the way you want to draw the cube. I am drawing the cube like this. Now the capacitors are here, one capacitor, here this is another capacitor, here there is another capacitor. So there are 12 number of capacitors, because a cube has 12 edges. This is one edge, this is another edge, this is another edge, this is another edge. So you count, there will be 12 number of capacitors in this circuit. Now my question is to get net capacitance between the point A and B. Look, only B point is changing. Terminal points are changing. First terminal I have solved between this point to this point, body diagonal. Then I have solved between this point to this point. This is the one face diagonal. Then I am solving between the point A and B, that is called one edge of the cube. This is only three type of structures can be obtained for the combination of capacitors. To solve this problem, so let the all capacitors are C, all capacitors are C. Now same process, let us take a battery. Same process, let us connect a battery and choose in which way current will be flowing and how to divide the currents. Once the current will be divided, the current division will be okay, then equipotential points will be obtained. Once equipotential points will be obtained, then problem can be drawn into parallel and series combination, and you can able to solve the problem. That is the motto. So in this course, let us start. Now, when the charge will be reaching here, this is the entry point, this is the exit point, this is the entry to this circuit, and this is the exit from the circuit. So now when the charge will be reaching here, the charge will go this way. Yes, this is only one path. Let the charge is x. This is only one path. Charge is x. So now along this path, now there is a capacitor. I have not shown here, there is a capacitor. Yes, there is a capacitor. So along this path, so how many capacitors it has to follow to reach the point B? So 1, 2, 3 minimum. There is no other path where the minimum capacitor will be less than 3. Only 3 is minimum. So 1, 2, 3. If we will go this way, minimum is 1, 2, 3. Since in this path is minimum 3, in this path also minimum 3, then I can say along this line charge will be Y. Along this line charge is also Y. So this is very important point. So now entry point. At the entry charge is X, Y, Y. So at the exit point also the same charge will be coming X, Y, Y. That is the symmetry sense. Now along this line is X, so here it will be reaching X. So here it is going Y, so here it will be reaching Y. It is going Y, so here along this path current reaching, charge reaching or coming to the exit end will be Y, Y, X. Current entering into the cube X, Y, Y. So this is the only idea will help you to solve the problem quickly. Next point is, let us find out the equipotential points in the problem. Who is the equipotential point in the problem? Look here. The capacitor is C. This capacitor is C. So charge is Y. Charge is Y. So potential of this point, potential of this point. These 2 point potentials are same. Let name of the point is P. Name of the point is P. Note down. This is very important. Just please listen carefully. How I am deciding equipotential point? Because capacitor charge along this path same. So potential of this point P, potential of this point is also P. Come to the other side. If you go to the other side, so capacitor C charge coming to this point is Y, C coming to the point Y. So potential of this point and potential of this point also same. Left the point, this name of the point is Q, name of the point is Q. So potential of this Q and potential of these 2 points are same. Potential of this point are same. But P and Q have different potential. So this P and this P are same. This Q are same, and all potentials are different. So next another 2 points are left. Let the point is equal to M. This point is equal to N. So this is the renaming of the system. Once renaming of the system is over, then what to do? How to solve the problem? So now this is another method to solve the problem, that is using the Kirchhoff's law also. But we are not using the Kirchhoff's law to solve the problem. We are using to solve the problem by using the parallel and series combination, or by using some symmetric sense, or by using the equipotential points. This is our motto to solve the problem here. Look, the point is, this point is A, this point is B. So I am drawing the figure nicely. Everybody please carefully with attention listen. This is the point A, this is the point B. From A to B there is a capacitor. From A to B, this point is B. From A to B there is a capacitor C. Let us join. From A to B there is a capacitor C. I am connecting here. Yes, this capacitor, let us put a tick mark. So this capacitor is over, connected between A and B. This capacitor connected between A and B. Connected between A and B. There is a point P close to A. There is a point Q close to B. So now let us come to a point P close to A. Let us come to a point Q close to the B. Again, P is close to A. P is close to A. Q is close to B. Q is close to B. Then let us go on connecting between A to P. Now from A to P there is a capacitor. Again A to P there is a capacitor. Look, from A to P this capacitor. From A to P this capacitor. Similarly, Q to B one capacitor. Q to B another capacitor. Now let us connect from Q to B. So once you will solve the problem by yourself again, you will find out it will be easier. So now P to Q, then A to B over. So which capacitor? This capacitor, this. Then another point is next capacitors are from P to Q. Another is from P to Q. This capacitor is from P to Q. This capacitor is from P to Q. This one is from P to Q. This is also from P to Q. Write down from P to Q. So from P to Q, So now this is C, 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 this is the Q point, this is P point. Now up to this I have derived. Then last point is, another point is from P to M, then Q to N. Now another points are there, 2 points are there. This is a point, this is a point M. This N is close to P, close to P. This N is close to Q, close to U. So now give another point here. This is equal to N. From P to M, this one connect. P to M, connect this one. Then again similarly, then M to N, one capacitor. Now look here, the capacitors are now rearranged like this parallel series connection, and finally I have to get what is the net capacitance between the point A and B. This is the restructuring of the capacitors in a sense of, or in an idea of how to get the equipotential point, how to decide equipotential point, that I have explained. Now this is what I have redrawn. Once it is redrawn, then we can get the answer. Now we are reaching the answer now quickly. How? Look. Between the point P to Q, so these two are parallel to C. This is C, again this is C. Now let us step by step, let us come down. Now the point is, one point is P here. Please follow, this is the point P. This is the point Q. Now from the point P, so there is a, from P to Q, these C are parallel. So like connect a capacitor, this is equal to parallel to C. Carefully listen. From P to Q, these two parallel, that is 2C. From P to M, parallel, so connect it, parallel. So this one, this is 2C, this is 2C. These two parallel, 2C. This is C, this point name was M, and this point was N. Now below the point P to A, now this is the point A, now this is the point B. Below the point P to A, two capacitor parallel to C. Again these two parallel to C. And between A to B, then the capacitor C. This is the terminal point A and B. Look here, now the problem is coming to closer to the answer. Because is now coming to closer to the answer only by the combination changes, and you are getting the answer. So now 2C, C, 3C, they are in series, in parallel to this. This, again series, parallel to this. Then we will be approaching the final answer. This is what? So we are proceeding to get the solution. Please note down. Everybody please note down the solution. Now I am erasing this part. Now come to this part here. So here, look again. This one, 2C, 2C, C. These three are in series. These three are series. If these three are series, so you know 1 by C dash is equal to 1 by 2C plus 1 by C plus 1 by 2C. LCM is 2C. 1 plus 2 plus 1. That is how much? That is equal to 4 by 2C. So C dash is equal to C by 2. That is C by 2. Or directly you can also say 2C and C, 2C series. So this 2 series is equal to C, and this C again series. So it will be C by 2. Directly also you can get the answer. So when it will be in practice, so you can also solve the problem quickly. 2C, C, and C again series, because series, that is C. So this comes to be C by 2. Now let us draw the diagram here. Now this is the point P. So now this is point Q. So all the steps I am solving so that you can follow and there is no problem for you to understand. So all the steps I am solving step by step. Now this is the point A, this is point B, this is equal to 2C, this is equal to 2C, this is 2C, and this combined form to be C by 2. That is equal to C by 2. So this problem is converted to this category. So again let us check. This is C, 2C, 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 and this combination becomes C by 2. This is the restructuring. Once this part is over, now let us remove this part. So this part. Now see the figure, this figure. Now tell me what to do. Now 2C and C by 2. So 2C and C by 2 are in parallel. They are in parallel. If the parallel net capacitance is 2C plus C by 2, it is equal to 5C by 2. So this is 5C by 2. So 2C, 5C by 2, 2C. Now let us make another diagram. So now again you are about to get the answer. That is 2C. This is A point. This is B point. This is C. So these two combined is 5C by 2. 5C by 2. This is equal to 2C. This is equal to 2C. Next point is only one step is left to get to our solution. The next step is, so 2C, these are all series. So net capacitance will be 1 by C dash is equal to 1 by 2C plus 2 by 5C. This one, 2 by 5C plus 1 by 2C. So LCM is equal to 10C. It will be 5. It will be 4. It will be 5. Look, LCM is 10C. It will be 5. It will be 4. It will be 5. So it will be coming how much? 14. So it will be coming 14 by 10C is equal to 1 by C dash. So C dash is equal to 10C by 14. It is equal to 5C by 7 C dash. So combinedly these three is found to be 5C by 14. Sorry, 5C by 7. Now only one step is remaining to get our solution. So the net capacitance between the point A and B, how much now? So the net capacitance between A and B is equal to, this is equal to AB. See, this point is A, this point is B, and this is equal to 5C by 7. So the net capacitance between AB about the edge of a cube, is equal to C plus 5C by 7 is equal to 12C by 7. So this is the answer to the problem. So what is the capacitance about the edge of a cube, that is equal to 12C by 7. Okay, so this part I am removing, 12C by 7. Look here, another important part. So I am going to explain here. Everybody please look at here. Now this is the cube. Now this is the cube. Now the capacitors are connected like this. Please go through it carefully. So I told you what is the net capacitance between these 2 points. This is B point, this is your A point. So now all capacitors are C. Then I have obtained that net capacitance between the point B is equal to 12 by 7C. How it is obtained? That is equal to C plus 5C by 7. This one. That means, so now except this one, all capacitors are found to be how much? 5C by 7. And this capacitor is in series, this one, 5C by 7. This is the combination of all these three. This is the combination of all. This one. This is the combination of up to this, all above. It is found to be, this is your C, and all other above, that is equal to 5C by 7. That is A point, B point, and answer is equal to 12C by 7. Now interesting part is, there may be a question in the examination, find out the net capacitance of the system if this is not there. So this is the cube and get the capacitance of this cube now. Suppose the question will be asked, find out the net capacitance of the cubical structure. One capacitor is not there. Answer is 5C by 7. Answer is 5C by 7. That is what we have obtained. This is the interesting part. So you please note down. This is 5C by 7. Or if you add it, it will be 12C by 7. This is the end of the problems of the capacitors in a cubical structure. Next video, so we are going to solve some problems using Kirchhoff's law, how to solve the problem. This will be your last problem regarding combination of capacitors. So now I hope you all like my video classes. If you like it, please subscribe and share it. Thank you.